So just in summary, in the studies that you've done, you've tested BDNF levels just through a simple blood test. Is that how that you've been able to do that?
Correct. What
Okay.
we do is, for many of our studies, we've based a lot of our work on acute changes in the human body. And we can do that because our company produces fruit, vegetable, and grain-based materials. We're not dealing in drugs or OTCs of any kind like that. So we go directly into people. We don't do animal studies. We don't do in vitro studies. We don't really think they necessarily prove anything. It's what happens when you ingest it, and then what we do is we'll ask our study participants to not eat anything after midnight. They come in fasted. We do a baseline blood draw, after which they ingest the tested material, and over the course of the next 4 to 6 hours we do periodic blood draws. Oftentimes it's sufficient to do a finger stick and take a few milliliters of blood, or in other cases we need a little more, so we go into the venous supply, and then we can run all sorts of analyses from that. And from what we do, then we crunch the data and look for changes.
And in terms of what people might feel after a couple weeks or months or longer on this, is that something that's still kind of ongoing? Is that correct then?
Well, the premise is that all of these gene expressions are switches. For example, the active form of vitamin D, calcitriol. You can take all the vitamin D you want, but it only becomes really useful when it's converted in your body into calcitriol. But you wouldn't want your calcitriol levels to go up and stay up, because calcitriol over time can be toxic. Calcitriol is a signaling or a trigger mechanism. It goes up, it spikes, and it goes back down, but it initiates a whole cascade of healthy, beneficial events downstream. Same thing with BDNF. The premise here was that we're trying to stimulate the BDNF gene to express and temporarily cause a spike in the level of BDNF, and the theory is then downstream benefits will occur. So we haven't done any long-term studies in terms of that, but these new studies are going to be, longer duration, a week, 2 weeks, a month, and we'll see if there are changes there.
You talked a little bit about toxicity of certain products. Talk about the safety of Neurofactor and the dosing as well, and what you've determined there. A lot of people think, well, if it's from a natural product, then more must be better.
Yeah,
what have you found so far?
Contrary to what our industry has always thought, and I think a lot of it's driven by Western thought that anything worth doing is worth overdoing, we've discovered that less is often more. And certain antioxidant products, certain products that cause expression of certain genes, we found that if you increase the dose beyond a certain point, you actually cause things to start shutting down. So we do dose response studies to try and optimize what might be the best target serving range. And then we also do toxicology studies. For example, on our coffee fruit extract, this Neurofactor we're talking about, we spent 18 months of long-term toxicology studies. We looked at everything from mutagenicity to cytotoxicity. We did, full necropsies, checking out how livers, kidneys, hearts, lungs, brains were affected. We brought in qualified toxicologists and published a paper on the safety of this material, and actually it's self-affirmed GRAS at this point. So we're quite confident of the safety of it, and we're really pleased to be able to report that all of the activity we're seeing is only at 100 milligrams per serving. So it's very small. which is, you know, a really good thing.